Hey everybody, this is Alex Merced, and you're listening to Gnarly Data Waves. And in this week's episode, we're going to be talking about enabling data mesh with Dremio Arctic and data as code. An exciting topic. Two of my favorite topics, the data mesh and data as code. Exciting trends that we're going to see how they collide in exciting collidingness today. Now, basically, before we get to our feature presentation, of course, you know I'm going to remind you to head over to dremio.com and try out Dremio Test Drive. You head over to dremio.com, click that little test drive button, and it'll give you an opportunity with no commitment, no obligation, at no cost to try out and get hands-on with Dremio so you can see what it's like to query your data lake, to have these data lake house type patterns. Okay, see the power of the data lake, take Dremio out for a test drive, go check that out. I'll see you there. Also, make sure to get yourself an early copy of Apache Iceberg, the Definitive Guide. Again, this is the book being co-authored by myself and many of the others here at Dremio, coming from O'Reilly, slated for early next year. You can get yourself an early copy of the first chapter by scanning that QR code right there. Okay, and again, upcoming episodes here on Gnarly Data Waves. Next week, we'll be getting started with Dremio. Then the week after that will be automatic data optimization with Dremio Arctic. And the week after that will be unified access for your data mesh, self-service data with Dremio semantic layer. And then easily migrate Hadoop workloads to AWS with Dremio, and then how MSK accelerates cancer research with Dremio's data lakehouse. Make sure to catch all of these episodes. And again, if you can't be there to see them live, make sure to watch them after the fact by either subscribing to our YouTube channel, youtube.com/Dremio, or on Spotify or anywhere you listen to podcasts. Just look up Gnarly Data Waves. Okay. And of course, we're going to be having the Dremio Data Hops tour stopping at a city near you. So if you are in one of these cities, make sure to stop by at the date for your presentation. Yeah. So I think there should be a few of these less to go. I will be at the New York one. Okay. So if you're in New York, April 27th, come join me at that Data Hops event. And again, now for today's feature presentation, enabling data mesh with Dremio Arctic and data as code. Okay, and with that for us, this presentation, we're going to have Jeremiah Morrow. Jeremiah, who is a director of product marketing here at Dremio. Jeremiah, the stage is yours.
Hi, everyone. My name is Jeremiah Morrow, and I'm responsible for product marketing for Dremio Arctic here at Dremio. And today on Gnarly Data Waves, I'm going to be talking to you about how data as code enables data mesh. Here's a quick agenda for this session. First, I'm going to level set by talking about what a data mesh is and why it's gained so much traction, especially over the last year. You see everyone talking about it. Then I'm going to talk about data as code, and specifically the data as code functionality within Dremio Arctic. Then I'm going to put those two concepts together and show you what a data mesh architecture could look like with Dremio Arctic as your data lakehouse management service, and then some of the benefits to the central data team, as well as domain owners and data consumers. Shouldn't be a long presentation. No one wants to hear me talk that long. So we should have plenty of time for Q&A, and Alex and I can answer some of your data mesh and data as code related questions. So to kick things off, I think it's really helpful to start with what is a data mesh. There's a lot of hype around the term. A lot of companies today are trying to fit themselves into this trend. And as with any emerging trend, there's also a lot of confusion around the concept. So a data mesh is a modern approach to data management. It emphasizes distributed ownership and governance of data within teams, which in the data mesh world is called domains. And it encourages those domains to think of data as a product. So they build, they manage, and they share data products across their organization with other data consumers who can then leverage that data for analytic insights, data science, et cetera, et cetera. Makes a lot of sense. We've been living in this world of distributed data for decades now. Public clouds have definitely added a new wrinkle with cheap, efficient storage for a lot of different types of data that is disparate from a lot of our other systems. And if we believe that the future state of most enterprise companies who are not born in the cloud is hybrid and multi-cloud, where we pick the best infrastructure on a workload by workload basis, then the idea of a single central data store is pretty tough to imagine anyway. And even if you are on the journey to a centralized data lake, a lot of companies are. I talk to a lot of customers who are on that path. Even really ambitious companies can still take years for their cloud migration. On the other side, most organizations can't wait years for a unified view of their data. Meanwhile, in most organizations, you have this tension between central IT and the line of business. With a mission critical asset like data, there's this really important balance you have to strike between speed and ease of access to that data, and also keeping that data safe. Depending on where you find yourself on this divide, you probably care a little more about one of those issues than the other, but they're both becoming way more important in our daily operations. There is a giant spotlight cast on data as lines of business recognize the potential competitive advantage the data can add, and also as cybersecurity attacks and data breaches become sort of a more common thing and a regular occurrence. So one of the potential answers to these two trends of distributed data and the tension between central IT and lines of business is a data mesh. If we implement this properly, we can address the needs of the line of business from an analytics standpoint and a data access standpoint. And we can also satisfy the requirements of central IT for security and governance. And we can make a distributed architecture and distributed data work for us instead of against us. But it obviously needs to be implemented the right way. You've probably heard this before as well, but data mesh isn't just a technology or a technology stack. So here's the next fun word you can drop at a happy hour with your friends, socio-technical. This is a socio-technical initiative, meaning that it involves people, processes, and technologies. There are elements of all three to implementing a data mesh. The people part is really simple: organize people around data. This whole concept is based on the idea that domain experts know their data and their data needs better than anyone else. And data mesh empowers them to put that knowledge to use for the good of the organization. The second part is processes. So the whole goal of data mesh is to make relevant data easier to consume. And so from a process standpoint, we need to shift to a self-service mindset and empowering both domain owners and data consumers to be able to manage and consume data. And that's really important to the success. Collaboration is also necessary, especially from a governance perspective, to make sure the data is easy to access, but also safe from any potential cyber attacks. And finally, there's technology. In a nutshell, a data mesh architecture needs to centralize security and governance while distributed ownership and management of data products. Data products need to be easy to access, they need to be easy to join and query, and the execution engine needs to deliver very high performance analytics. Nobody's going to look at a dashboard if it takes forever to load. I'm not here to tell you whether or not you need a data mesh. Every organization is different, so are their needs. Data mesh is one solution to a common set of challenges, but there's plenty of validity to the idea that a central data lake is also the answer if you can overcome their challenges. So I'm going to go over a few of the pros and cons of a data mesh, and then we're going to talk about data as code. First pro is that domain owners know and understand their data better than anyone else. There's nowhere in analytics that this is more obvious than in data science. In data science, if you're trying to deploy an AI or an ML model, cross-functional teams that include domain experts are much likely to have success in actually deploying an effective model in production, because those business owners have all of the context around what data is and isn't important. So if you want to build a high value data product, domain expertise is absolutely necessary to understand what you're looking at. Second pro, if you have the right tools, analyzing data in place without making data copies or moving data around is much more cost efficient. Easily one of the biggest causes of sticker shock on most organizations' cloud bill is ingress or egress charges. So that to the extent that we can limit data movement and data copies, we can reduce that sticker shock, at least as it pertains to analytics. The third thing is it may not be possible to move all data into a central repository. So a data mesh may be the only way to view all of your data, have a single unified view of all of your organizational data. We have, for example, a multinational utilities company. They chose to leverage a data mesh because they were not allowed to move certain data across country borders. And so domain owners had to ensure that that data that they were allowed to share across domains is available to the organizations, and other data is scrubbed out and remains in place. In addition to those three, there are, of course, drawbacks. There is a caveat to all of these that they can largely be mitigated if you have the right tools in your architecture. For example, security and governance is more challenging than in a centralized architecture, unless you're leveraging tools that enable consistent security and governance across multiple domains. Second is data talent. You may not in your organization have access to the talent that you need to build and maintain data products across multiple domains. So to the extent that you can choose tools to implement your data mesh that are very easy to use, and to the extent that you're able to enable collaboration, that's going to be critical to your success in a data mesh. Third is that it's often difficult to ensure self-service access and high performance analytics on data across multiple domains. And it's even more difficult to do that on a consistent view of the data. And this third bullet is really what we're going to be discussing from a data as code perspective for the bulk of the rest of the webinar. So now I want to talk about Dremio Arctic and data as code. So first, if you are unfamiliar, Dremio Arctic is Dremio's lakehouse management service, and it's based on Project Nessie. In a nutshell, think of it as the house component of the lakehouse. So it gives data teams and domain owners, in a data mesh example, a lot of tools to effectively manage and govern data in the data lake. So it's a lot of things. It is a modern lakehouse catalog. It also features automatic data optimization, like compaction and garbage cleanup for Apache Iceberg tables. And it also gives teams data as code capabilities to make it really easy to deliver a consistent and accurate view of the data. If you want to learn more about Dremio Arctic, Tomer Sharan talks a lot about it in the subsurface keynote from this year. So go back, take a look. He even talks about a lot of data mesh concepts. So feel free to view that on demand. Let's talk about some of the data as code features within Arctic. So data as code is the practice of managing data just as you would manage code in software development. And what I love about the data mesh conversation is that that analogy becomes even more direct if you think about data products as software applications. So if I'm shipping an application, I would never make it generally available to a customer, whether that customer is internal or external, without rigorous quality assurance and rigorous testing. And I would want to ensure that all of my customers had access to the latest version of my application, the most high quality and highest tested version of my application. And data as code makes shipping data products very similar to shipping code in a software application. Dremio Arctic uses three capabilities that we're going to talk about a little more. And those are branches, tags, and commits. And branching, tagging, and committing makes it really easy to develop, test, and deploy high quality, accurate, and consistent views of the data, and to make that data easily available to data consumers to join and query. I covered a lot of these concepts in a webinar last month on data as code. This is more of a refresher, so feel free to look that up and watch it on demand. But I'm going to go through them right now very quickly. So the first concept is branching. When you create a branch, you're essentially creating a virtualized view of a table in your data lake at a specific point in time. It's not a data copy. They're metadata pointers. That's a really important distinction. This is still a no copy architecture, but branching enables you to do a lot of things with the table without making changes to the main or production branch of the table, the one that everybody's accessing and using for analytics. You can create an ETL branch. You can merge that data into the table. You can check that branch for quality, make sure there are no missing values, extra rows, things like that. You can do transformations. You can create an experimental or data science branch. The point is, everything you do on that branch happens in isolation, and it doesn't impact what data consumers see in the production branch of your table. Tags, on the other hand, help you identify different versions of a table to reference or retrieve. They make it really easy to track the history of a data product over time, for example. And they help data teams within a domain or across domains collaborate on a data product. And finally, commits are a snapshot of the table at a specific point in time. So if you make any changes to a table in a branch, and then you commit those changes, the changes are applied atomically to the production branch. That means that with commits, data consumers never see a partial or incomplete view of the data. Commits are all or nothing. And commits also help with collaboration because multiple users can work on the same table without interfering with each other's changes. Each of the users' changes are present in different commits. It's also really easy to revert back to a previous version if necessary. So hopefully, as I've been talking through this, you can see a little bit of the value of data as code and what it can bring to your data mesh architecture. But to make it hopefully a little more real, I'm going to walk through some of these data mesh architecture slides, and hopefully it becomes more apparent. So we'll start with the foundations and build from there. So first, let's look at an organization that has several different functional areas. Three of these areas are sales, marketing, and product. Within Dremio data mesh architecture, you would have isolated environments. In the Dremio world, we call these spaces for each of these departments. Of course, if I wanted to, and if my data team enabled it, I could access data products in other spaces outside of my own, which is where the centralized governance and security comes into play. Each space would be a separate domain in a data mesh. Within each domain, you may have a variety of data products that are built off of data sources. And those data sources can be cloud data lakes, they can be on-premises HDFS, they can be different applications that generate data like CRM or ERP. Systems. They could be relational or NoSQL databases, and so on and so forth. Domain experts can easily and safely join data together across these different sources. They can experiment, they can do some last mile transformations, etc. Importantly, all of this occurs, again, without moving or making copies of the data. We are very much a no copy architecture, and the data remains in place. So these views exist as SQL statements, but they can be accessed as data products by other data consumers as long as they're made generally available through spaces. So this is the foundation of a data mesh, and it's something that dozens of companies have implemented with Dremio. Now let's zoom in a little bit. Let's see how data as code builds on the foundation of a data mesh. And we're going to zoom in on an ETL example. So let's say the marketing department regularly ingests new web traffic data, and they want to make it available as a data set to the rest of the organization. So within Dremio Arctic, that data would reside in a table in their data lake. One of the big challenges with a distributed data architecture is delivering a consistent and accurate view of the data. And so that's the problem we're solving with branching. With Dremio Arctic, they would have their main or production branch that data consumers can access and can continue to access even as this ETL process takes place. To bring new data in, they would create an ETL branch. Then they would merge new data into the table. From there, they could do things like perform a quick quality check to make sure there aren't any missing or incorrect values, no weird or extra or missing columns, nothing like that. They could even query the new branch and make sure their dashboard loaded properly and that the new values were present and that it was showing the most recent version of the data that they have in their branch. And while they're doing that, again, keep in mind that the ETL branch is not generally available. And so all of this work is happening in isolation from the production branch. So in the event that there's an issue, no data consumer is impacted and everybody is still seeing one consistent view. Once the marketing team is confident that the data is correct and their data product is high quality, they can make a commit, and that merges the ETL branch to the main branch. All of those changes are made atomically, and all data consumers now have access to the latest and most accurate view of the data. So that's how data as code helps domain teams create high quality, accurate, and consistent data products and delivers those back to the business. Once those products are built, Dremio makes it really easy to share across domains with a semantic layer. You can add business context, you can add tags, you can use wiki features on your data products so that users in other departments and other domains can easily identify the data sets they want to leverage. You can also track how often those data sets are being accessed and leveraged so that you also know which data that you have is most valued to the organization. And it's easy to consume data. Users can join and query data across multiple domains and use their favorite tools, whether it's a BI tool or a visualization tool. We obviously have integrations with many of the most popular BI and visualization tools out there. They can easily join and query data from multiple domains, again, to emphasize that they're not creating data copies or moving data from its source. And multiple concurrent users can work on the same data sets without impacting each other. So really easy to see in this example how you could get a quick customer 360 from marketing data, whether it's web traffic or webinar attendees, and how those customers are converting via early stage opportunities. Or what clouds they're using, and then using product information to understand who's really active and what their feedback is from an NPS standpoint. And so that's a customer use case, and all of that data can be joined and queried by anyone in marketing, sales, or product. So there are a lot of advantages and benefits to data as code for data mesh architectures. In fact, nearly every benefit of data as code can help you if you're on your data mesh journey. But I only had so much room on this slide. So here are my top three favorites, in my opinion. The first is collaboration. Tagging makes it really easy to identify different milestones in the life cycle of a data product. Commit history makes it easy to see who made what changes. And with branching, we have an easy way for multiple people to work on the same data product without impacting each other, as again, commits are made atomically and separate from each other's changes. Consistency is critical. I think consistency in the data is what truly separates a data mesh from data silos, along with the no copy architecture. So by using branches to make changes, data consumers are always accessing the same consistent view of the data. I've talked to a lot of companies who are still working on Excel spreadsheets for analytics, where they spend the first 15 minutes or more of their meetings trying to reconcile multiple different versions of the same report. That makes it impossible to arrive at a sound data-driven decision in any length of time. So by making changes in isolation and using atomic commits, no one's looking at an impartial or different view of a data product. Everyone has access to the exact same information at the exact same time, and they don't have to waste extra time figuring out who actually has the source of truth. Data consumers with a consistent view of the data can spend their time actually talking about what the data means instead of what the data is. And the last one I want to highlight is quality assurance. Data products are truly just like software applications. The best thing that you can do across your organization to encourage adoption of a data-driven approach to solving business challenges is ensure that you are all delivering high-quality products. And data as code not only accelerates the development and delivery of high-quality data products, they also make it easier than ever to make changes and to test those changes before making any updates. It's also incredibly easy to recover from any mistakes by reverting to a previous table state, and it just takes a few seconds. So that's all I have in terms of the formal presentation today. If you want to try Dremio Arctic, it's available for public preview within Dremio Cloud on AWS. And it's free to try today. Check it out at www.dremio.com /get started. and you can sign up today. We can also set you up with a personalized demo of Arctic if you want. Ping me on LinkedIn or via email if you're interested. I am more than happy to help you get started. Thanks again, and I think we have plenty of time for Q&A.
Welcome back. Now it is Q&A time. So let me just queue up the Q&A. Again, if you have any questions, please put them in the Q&A box. So let's take a look. Our first question is data mesh versus a data lake. It's not a binary decision. You can have both and they can easily coexist. This is absolutely true. Data lake and data mesh are different types of architectures that aren't mutually exclusive. Like in a data lake, essentially I am, let's say, setting up a place where I can store large amounts of data for analytics. But at the same time, the way I deliver that data, the way I govern that data can be done in a data mesh style where we do have those different domains. We do have that computational governance where we have basically decentralized creation of the data, but oftentimes centralized governance and distribution of the data. And kind of so that way you have those who are closest to any chunk of data kind of working on that data. So yes, they are not mutually exclusive, but the idea definitely a tool like Dremio Arctic and Dremio as a whole can really make executing a data mesh much easier because it does allow you to have many people working on the data, but at the same time you have one place where you can sort of organize and govern that data. So that way you do have that computational governance, you have that nice separation of domains. It really kind of really lends itself to that just by chance.
And I think Alex, based on when that question was asked, the person who asked it probably focused on data lake versus the idea of a centralized data lake. So that's the difference between data mesh and the centralized data lake is the centralized part. So the question is, are you going to store all of your data or leave all of your data in where it's or closer to where it's generated within the domains, or are you going to move all of that data into one data lake where all of your data lives? And is that going to be governed by central IT? So I think that was what they were focused on.
100%. Okay, so let me just mark that one as answered. Okay, what if several processes mutate the same data in parallel? Will we have an exception on merge? Okay, so here we're getting into the nitty-gritty of Arctic's branching feature, and this has to do with how the underlying open source project Nessie works. So basically this answer particularly will evolve. Okay, so right now essentially the way Nessie is working is that every time you do a transaction on a table, it's capturing a snapshot of the entire catalog. So essentially if you dive into like sort of how Apache Iceberg works, the catalog mechanism is essentially capturing, okay, hey, here's where the metadata is for each individual table, and each table sort of tracked individually. What Nessie is doing is not only is creating basically a commit at the catalog level of all those locations. So then when you create branches, you're just creating a branch of those commits. So basically now you have branching at the table level of the table level commits, which is now native to Iceberg. And then you have Project Nessie, the open source project, which allows you to have catalog level commits, which gives you the benefits of like catalog level rollbacks, to be able to do branching, all that stuff. But right now, the issue is like, what if I have many branches and they all do conflicting changes? Right now, the level, this is something that's going to improve and that's constantly being worked on, is Nessie's ability to kind of reconcile those branches when you merge them. So right now it does a fairly like shallow merge. So generally the best practice at the moment would be generally to stick to like, hey, I have an ETL branch. Okay, so I create that ETL branch, merge it back in. You're not going to run into any problems. And then your experimental branches are just experimental branches that generally don't get merged back in. You can have multiple branches that can be merged in successfully. It just depends on the specific things that get changed. But right now it's going to be much easier to hit a merge conflict than it will be in the future. So one of the things that should be added to the Project Nessie project in the very near term is more catalog level metrics. So basically what's going to do is not only just capture those metadata pointers, like, okay, here's the metadata, but also a lot of sort of metadata about the state of the catalog as a whole and the state of those individual tables. So that way it can, when you do those merges, it can reconcile more situations more often, so you'll be less likely to have those kind of merge conflicts, and it'll be able to kind of take, hey, 3 or 4 branches being merged into and basically
reconcile all that and make sure that it stays consistent. So right now, generally best practice, have one branch for ETLing. So essentially, like, you have your ETL job, you branch, you do the thing, you merge it back in, and then you kind of have it in a nice cycle where you're ingesting stuff. You can't, again, it is possible to have multiple branches. It's going to be even better in the future as far as those catalog level metrics to successfully merge in more situations when you have a lot of different branches with pseudo conflicting stuff. So that is a story there. So again, I would keep an eye on the Nessie project, because that's more has to do with the state of project Nessie, the open source project, which is what is the underlying thing that powers Dremio Arctic at the catalog level. Underlying source databases can have varying query performance. How do you manage the query experience when joining a table across these databases? Okay, so this sounds more of a Dremio question than an Arctic question. The reason being is that generally you'd be doing that in Dremio. So Arctic, generally, those are iceberg tables that you have in your Arctic catalog. But in Dremio, I can connect the SQL database. I can connect a different SQL database like MySQL, Postgres, and then I can join them with other thing I connected. Theoretically, I could take a Snowflake table, because I can connect Snowflake to Dremio. I can join it with a Delta Lake table that's on my S3, and join it with a Postgres table, because Dremio can connect all those things. But how do you manage the varying performance? There's a couple different ways that can happen. If you don't do anything, it is, let's say, I have a less than optimal Postgres server that's handling my Postgres database. Yeah, that could end up being a bottleneck on those queries. But Dremio has a really cool feature that can address that issue, and that's called data reflections. So what you would do is that if you have a particular table that you join a lot in Dremio, for, like, let's say a Postgres table, okay, or even like that Postgres, that Snowflake, the Delta Lake table, all three tables I join, and one of them is a bottleneck. What I can do is I can turn on data reflections on all three, and what's happening under the hood is that Dremio is essentially making an iceberg representation of that table that it can then join. Okay, so that's one use case for data reflections, to help accelerate your virtualization of data. So that way, at the end of the day, you don't have to think about managing a second table. Dremio is essentially keeping it in sync with the underlying source under the hood. So it makes virtualization a bit more practical. But then data reflections, if you had actual iceberg tables natively in S3, you can use them to create all sorts of special use case versions of it. So for example, if your iceberg table is sorted and partitioned in one way, you can create a data reflection that sorts it and partitions it in a different way for different queries that might benefit from that alternate version, but you don't want to have two separate tables. Dremio will kind of manage those representations under the hood. So data reflections is really the key, the secret sauce to anytime you have these like weird edge cases that could affect performance, data reflections usually smooths that out. And data reflections does it in a way that gives you a lot of bang for your buck, because it's not just creating a copy of the table. What it's doing is creating like composable pieces of iceberg tables, and they can use them and mix and match them based on what's kind of going on in the context of the query. So that way you're not storing as much data for those materializations, but you're getting more use out of them because they can be used not just on that data source, but on all the views based on that data source, depending on the context of the query. So it's super cool. Okay. How does data as code generated in Dremio? Is it driven by a graphic user interface? Okay, so the story here is that when you say data as code, at the end of the day, it's all project, like the Project Nessie catalog. And the Project Nessie catalog has basically a REST API that underneath it that allows you to send it different directions. Now, when you're using Dremio and many of the extensions to Nessie, what it does it through SQL. So I would essentially write SQL, and like the Spark or the Dremio implementation of Project Nessie will take all that SQL, run the processes, and then use the Project Nessie's REST API to send the directions to make the appropriate updates to the catalog. So essentially, at the end of the day, it's still driven by SQL, but on Dremio, you do have a graphical interface that you can use to give certain directions, like create branches, merge branches, and it's essentially just making the appropriate API calls to the Nessie server underneath, because it's all done through that standard REST API to do that. So the Project Nessie catalog, that's the thing that really drives the data as code and the branching and the merging. That the interface is a REST API, And then again, those interactions based on the particular software you're dealing with will just make the appropriate calls to that API. But you don't have to manually make those calls. So I think that answers the basic idea is you can do both. You can have a graphical user interface and you can write code. It just has to somehow interact with that REST API at the Nessie catalog. Are constraints like row level security included in a branch and merge to on commit to master? That's also an evolving story. As I understand it, like the amount of branch level security you can do on Project Nessie is going to continue to evolve. So essentially, yes, like you'll have the ability to do really granular controls on each individual branch. And essentially when you merge one data to another, the security controls that you're subject to are based on whatever's set on that branch. So you merge the data in, so the ETL branch may have one set of controls and the main branch might have another set of controls. The minute you merge that in there, it's now subject to like the main branch's set permission controls. So if that has like public or, more wider access controls, that data now becomes more widely accessible the minute you merge it, because it's now part of that main branch, subject to that main branch's data access rules. So there's a couple, that's evolving. And I think there's some level of that already in the UI. And then Dremio itself already has very, very detailed controls at the dataset levels from Dremio Sonar. But all that, again, is going to become more branch centric as Project Nessie evolves.
One thing I should address, because we get this question a lot, can I see it in action? Alex actually did a fantastic demo that is now a standalone video on our last Dataascode webinar, where he showed a QA branch and merging that branch into the main. So we will include that in the follow-up resources after this webinar, so you guys can see it in action.
Check that out. And then we also have several blogs that we've done that where you can basically, it'll allow you to kind of spin up, either use Dremio Arctic natively, or there's a couple articles where we use Project Nessie and you spin up a Docker container with Project Nessie and interact with it either via Spark or Dremio. So check those out. So that way you can actually get hands on and actually just kind of see it up for yourself. At the end of the day, it's, even if you don't necessarily like a lot of people they're like, well, maybe I don't need branching, but you still want the catalog level commits, because the catalog level commits, just a couple scenarios where just being able to have those catalog level commits becomes really useful. Is imagine on a Friday, you have an ingestion job that goes wrong and you've just ingested bad data into 100 tables. Okay, with just table level commits, you would have to go back and individually roll back those tables one by one. But with something like Project Nessie, where you have those catalog level commits, you can roll back all those tables in one operation, which can really prevent a very long weekend. So things like that. So there's a lot of different use cases where having that catalog level abstraction can become really, really useful. Are there any use cases where re-latency becomes a concern limiting factor with cross geography, cross view data products, or cross business unit? Re-latency, let me see, where would re-latency be coming from? I mean,
I could see that being a challenge for something if you're trying to get like true real-time performance, for example, like microsecond. But with a lot of our customers doing data mesh and joining and querying data across different geographies and different BU data products, we still see sub-second performance. So I think as long as you're not trying to do something that's like microsecond, which is not really a Dremio use case anyway, generally you're still going to get reporting in sub-second time.
Yep, 100%. And the thing is that it's even easier because Dremio Arctic has those automated table optimization features that should actually even make the tables more easier to query faster more of the time, because it's doing that compaction and all those other optimizing features for you under the hood, so that way you don't have to worry about maintaining those tables in their most optimal form. So that's a nice bonus that you get with that. So there's the actual Dataascode features, but then again, it's actually managing the data for you, and that definitely goes a long way, because oftentimes scheduling and organizing that kind of work can be really, really painful. Okay, not connected to webinar question. What options do we have to ingest data from Kafka to Iceberg tables if we don't use Spark or Glue. There is a Kafka sync. I'm pretty sure there's a Kafka sync. You could use Flink, you know, to ingest the data. You know, basically it'll go from Kafka, and then you would use, you know, from Flink you would use a Kafka source and then sync it into the Iceberg sync from Flink. I think Debezium has an Iceberg sync, so you could use Debezium. Like, yeah, but I mean, there is like I'm pretty sure there is actually, I think there's two Kafka syncs out there for Apache Iceberg tables. I think Good Data created one, and then there's another one created by someone else. So there are different options. I haven't used those personally. I've only done the AWS Glue from Kinesis to Glue streaming pipeline. But they're there. There are people that use them, and there is documentation out there on them. But yeah, so there's multiple ways of getting from Kafka to Iceberg. I'll give another 30 seconds for any additional and final questions going into the session. And just so you guys know, next week we'll be doing a getting started with Dremio session. So that'll be a good session that's just going to go over like what is Dremio, what is Dremio's use cases, a demonstration of Dremio, and some of Dremio's like more nittier and grittier features like a lot of those access controls and data reflections, which I talked about earlier. So if you're curious about how all that looks like in action, next week will be a really good episode on that. And then I think the following week is the week where we're actually talking about that table optimization feature that we mentioned earlier. That's in Arctic. So if you want to see that table optimization feature and how you can use that to kind of keep all your tables nice and crisp, make sure to be there for that. And again, this is always posted on pretty much all your favorite podcast platforms, basically a week, basically within 48 hours. So basically, if you want to listen to it again, or you want to share with a friend, it's going to be on Spotify, it'll be on iTunes, it'll be everywhere. Okay, Kafka Iceberg, a more comprehensive way, use CDC protocols. Databricks has a good one with versioning, time, real. Okay, so like that's just one suggestion of how you can go from Kafka to Iceberg. Okay, and then speaking of like CDC, let's change data capture protocols. There's actually a good presentation from AWS from our last Subsurface conference that also shows another approach to doing CDC with Iceberg. And then Iceberg just added natively CDC features. And I think Dipankar, our other developer advocate, either just came out with a blog on that or is about to come out with a blog on that. So I think it's coming. So keep an eye out for that one. Oh, here we go. Please send me a link for Iceberg CDC. Okay. Okay. Yeah, we'll post that, and then also make sure to follow Dipankar Mazumdar on LinkedIn. He's done a few posts on it recently. And then again, when that blog comes out, I think the blog hasn't come out yet. But it should be coming out imminently. We'll get you the link. But all the blogs are at dremio.com/blog. Cool. And any parting thoughts, Jeremiah, before we call it a day?
Nope. Thanks for having me. Really good conversation. And again, if you're interested in trying Dremio Arctic, either check it out on Get Started, or if you want some additional help getting started, please let me know. I'll get you in touch with some of our solution architects who can help you.
That's right. And again, thank you very much, Jeremiah. This is always delightful to talk about datascode. It's always a good time. And everyone, again, please join us again next week. Same bad time, same bad place. Again, make sure to also subscribe on Spotify, iTunes, wherever you listen to the podcast, or our YouTube channel, youtube.com/Dremio. So that way you never miss any of our content, whether it's a Gnarly Datawaves episode or any of the other content that we put out. But I will see you all again next week. Have a great day and enjoy.